Hello, you are listening to Pankaj Rai, and in this video we will be discussing the numericals of the chapter Thermodynamics. So let us begin with the topic in which we have to find the work done by gas in expansion or compression against a constant external pressure. Okay, so let's say that there is a gas whose initial volume is V1. Okay, now let's say the gas is expanding against a constant external pressure, or it is compressing against due to the constant external pressure, and there is a change in volume, and let's say the final volume of the gas is V2. Okay, so we can say that the change in volume of the gas will be V2 minus V1, that is final volume minus the initial volume. Okay, now you have to remember one thing, that if there is expansion, so the final volume will be more. So during expansion the change in volume will be positive, and during compression the final volume will be less, so change in volume will be negative. Okay, let's say the external pressure is denoted by, let's say, Px, standing for external pressure. Now during expansion or compression the gas will be doing the work, and that, let's say, the work done by the gas is represented by W. Okay, so the relation between all these terms is given by W is equal to minus P external into delta V. So this is the work done by a gas during compression or expansion against a constant external pressure at constant temperature. Okay, now what is this minus sign indicating? Okay, now this is very important and let us concentrate on this one. Okay, during expansion the work is done by the gas on the surrounding. Okay, so gas is actually using its energy to expand itself against the atmosphere, so it will be doing work, so its energy will keep on decreasing. So that is this minus sign indicating that during expansion the work will be negative. Okay, because as you might be aware that delta V during expansion is positive, so the volume expansion is positive, so this positive multiplied by positive pressure, and but we have to multiply by minus, which will be indicating that the energy of the gas has been reduced. In the other case, when there is compression, so the atmosphere is doing work on the gas for compressing it, so energy is actually getting stored in the gas, and when the energy is getting stored in the gas the energy of the gas will increase, so the energy will increase, that means work will be positive. So for that work will be positive, it will be automatically done if the equation is minus Px delta V, because you know that during compression the delta V is negative, so this negative multiplied by this negative will give us a positive work. So remember things like during expansion. Okay, during expansion the work done is negative, and during compression the work done is positive. Okay, and there is one more case. Let's say that there is no external pressure, let's say the gas is in vacuum, so it will keep on expanding without any problem, without even spending any energy. So if the gas is expanding in vacuum, that is there is no external pressure, so when external pressure is zero in vacuum, the gas will expand freely and it won't do any work, so the work done in that case will be 0. So these are the three cases of work done. During expansion it is negative, during compression it is positive, and in free expansion, that is in vacuum, there is no external pressure, so work will be 0. Okay. Now on the basis of this there are numericals which comes, and before going to those numericals we have to understand the terms and the units and the conversions. Okay, so I'll begin with force. Now as you know that force is actually mass times acceleration. Okay, so mass times acceleration, so it is mass is kg and acceleration is meter per second square, so that is the unit of force. It is also said to be Newton. Okay, next one, energy. Energy is same as work, and as you know that work is actually force into displacement. Now if work is force into displacement, so it would be force which is kg meter per second square times displacement which is meter, so it will be kg meter square per second square. So that is the unit of energy or work, and its SI unit is also the joule. This is also the joule. Okay, so you have to remember the unit of force is Newton, work is joule, but also their standard units which is force kg meter per second square and energy or work is kg meter square per second square. Now let us move ahead from this. Let us start with pressure. And as you know that pressure is actually force upon area. So its unit will be the unit of force which is kg meter per second square upon area that is per meter square. So that will be kg per meter second square. So that will be the unit of pressure, and it is also said to be, as you can say, force per area, so it can also said to be Newton per meter square, or pressure has a unit after the scientist as well, that which is Pascal. So these are the units of pressure. Okay, now let us begin. Now what about volume? Okay, now volume, as we know, has the units of meter cube. Okay, but sometimes the pressure and the volume are given in different units, like pressure is given in atmosphere and volume is given in liters. So how, and we have to find the work done in that case, and that will be liter atmosphere. Okay, so what about that? I mean all these things. So let us start. Okay, now there's a different thing which we are doing here. Let's say now we are having 1 liter. Okay, now you must be knowing that 1 liter is same as 1 decimeter cube or 1 dm cube, and 1 dm cube is actually 10 raised to minus 3 meter cube. Okay, you should be aware of this. Now the next thing is, what about 1 atmosphere? Now 1 atmosphere is actually 1.013 into 10 raised to 5 kg per meter second square, which is this one, exactly the same. Okay, so this is the pressure and this is the volume in the standard units, and the conversion from the liter and atmosphere to standard units. Okay, now let us see what is 1 liter atmosphere. Okay, so we are trying to see what is 1 liter atmosphere. So 1 liter atmosphere is like 1 liter times 1 atmosphere. Okay, now 1 liter, as we know, is 10 raised to minus 3 meter cube, and 1 atmosphere is 1.013 into 10 raised to 5 kg per meter second square. So 1 liter atmosphere will be 1.013 into this is 10 raised to 5, 10 raised to minus 3, so this will be 10 raised to 2, and this is meter cube per meter, so that will be meter square, so that will be kg meter square per second square. But what is kg meter square per second square? Kg meter per meter square by second square is energy or the work done. So actually this is the unit of work done as well. So we have 1 liter atmosphere. Okay, we are having here 1 liter atmosphere is equal to, I can say this is 101.3, okay, kg meter square per second square. I can also say that it is joule. So that is a conversion from liter atmosphere to joule. Okay, now on the basis of these conversions you can solve these numericals by yourself, and there are two sets of units which might be given to you, like work if given in joule. Okay, the external pressure has to be in pascals or newton per meter square or kg per meter second square, and the volume should be in meter cube. Okay, but let's say you have been given that work is in liter atmosphere. Okay, and at that point of time the external pressure has to be in atmosphere and the volume has to be in liters. Okay, so let's say you have been given work in joule, so from joule to liter atmosphere you have to like divide by 101.3, so you get the liter atmosphere. Okay, and let's say you have been given pressure in let's say pascals or newton per meter square. Okay, so to convert that to atmosphere you have to do this conversion, divide by 1.013 into 10 raised to 5, so we'll get in atmosphere. And let's say the volume is given in meter cube and you want in liter, so you have to divide by 10 raised to minus 3, that is multiply by 10 raised to 3. So either way you should be able to solve these numericals by these conversions. Okay, but the most important thing which you should remember is that suppose it is given to you that during expansion, okay, during expansion the work done is, let's say, 40. Okay, work done is 40. So if this is given, okay, you can't use w is equal to 40. You have to say, even if the question is stating that work done is 40 units, but you will write in data that w is equal to minus 40, and you have to use this equation only. Okay, and again let's say if you have been given that let's say you have been given that during compression, okay, during compression the work done is 40. Okay, so you have to take work done as 40 only plus 40, because during compression the work done is positive, and you have to use this equation only, and accordingly you have to use v1 and v2 during expansion. Okay, during expansion v1 will be small, v2 will be greater, so delta v will be positive. During compression v1 will be more, v2 will be less, so delta v will be negative, and accordingly you have to substitute and you will get all the values properly. Thank you very much.